All right, let's talk about the ESP32. Specifically, how to unlock its real power for all those battery-powered projects you've been dreaming up. We're going to focus on one single crucial feature. I'm talking the difference between your gadget lasting a few hours versus a few years. Ready? Let's get into it. You know the feeling, right? You've spent ages building the perfect little gadget. It's wireless, it's smart, it works flawlessly. And then you hook it up to a battery. Bam, dead in a day. It's so frustrating, and it basically chains all your best ideas to a wall outlet. Okay, so here's how we're going to tackle this. First, we'll break down the battery life problem. Then I'll introduce you to the ESP32's secret weapon, its deep sleep superpower. We'll look at how to wake it up, build a super practical sensor without even touching a soldering iron, and then wrap things up with that big question. Should you use a framework or just code it yourself? So let's start at the beginning. What's the deal with battery life? Why do these awesome little chips drain batteries so fast? Well, the truth is, when an ESP32 is fully on, CPUs blazing, Wi-Fi radio searching for networks, it is thirsty. It's a power-hungry little beast. It's like it's sprinting all the time, which is great for performance, but terrible for endurance. So if you're building something that needs to live out in the wild on its own, this always-on mode, yeah, it's a total non-starter. But what if the ESP32 had a secret weapon? A built-in feature designed to solve this exact problem? Well, it does, and it is an absolute game changer. It's called deep sleep. So what exactly is deep sleep? Think of it like hibernation for your chip. It's an ultra-low power mode where pretty much everything non-essential gets shut down. The main CPUs go dark, the Wi-Fi goes quiet. It powers down almost everything to sip the absolute bare minimum amount of power. And the difference is, well, it's just staggering. You've got active mode, burning through power, and then you've got deep sleep. The power draw just plummets. We're talking about going from something like 80 milliamps all the way down to maybe 10 microamps. That's, what, a 99.9% drop? It's insane. And that is the secret to building projects that can last for years on a single battery. Okay, so you're probably thinking, if everything's turned off, how does it wake back up? Great question. See? Almost everything is off. A tiny little part of the chip called the real-time clock, or RTC, stays awake. It's like the night watchman. It keeps time, holds onto a tiny bit of memory, and listens for instructions on when to wake the whole system up. That's the magic right there. All right, so we've got our device hibernating, saving all that precious battery life. Now for the fun part. How do we wake it up when we need it to do something? Let's check out the options. You've basically got three main ways to wake it up. You can use a timer, a capacitive touch pin, or some kind of external signal, like from a button. Each one is perfect for a different kind of project. The timer is definitely the most popular one. It's exactly what it sounds like. You just tell the ESP32, hey, go to sleep and wake me up in an hour. It's perfect for things that need to happen on a schedule, like a remote sensor that just needs to send a temperature reading back to base every so often. Then you've got the external wake-up, which is triggered by, well, an external event. And this one comes in two flavors. First, there's X0. That's the simple one. It just listens on a single pin. Think of it like a doorbell. One button wakes it up. Then there's X1, which is a bit more sophisticated. It can listen on multiple pins at once. So you could have a whole panel of buttons, and depending on which one you press, it wakes up and knows exactly what you want it to do. Okay, that's enough theory for now. Let's get our hands dirty, metaphorically anyway. We're going to build a smart air quality monitor, and here's the best part. You won't need a soldering iron at all. The hardware list is super short. All we need is a little Adafruit Cute Pi board, that's our ESP32 brain, a really cool all-in-one Grove environmental sensor, and a special cable that lets you just plug them together. That's it. No soldering, just plug and play. And this is where things get almost too easy. We're going to use a framework called ESP Home. So step 1, plug in the hardware. Step 2, write a couple of lines of text in a simple configuration file to tell it what you connected. And step 3, click a button to add it to Home Assistant. ESP Home does all the heavy lifting, all the complicated coding, completely behind the scenes. And boom, just like that, you've got a professional-grade sensor feeding live air quality data right to your Home Assistant dashboard. Temperature, humidity, VOCs, you name it. And you built the whole thing in, 10 minutes? That's the magic when you combine great hardware with a framework like this. So yeah, that project really shows off what something like ESP Home can do. But it also leads us to a really important question, one that every single maker runs into eventually. When do you use a framework, and when is it time to roll up your sleeves and write your own code from scratch?
I saw this quote on a forum that just hits the nail on the head. Frameworks are amazing for getting standard stuff done fast. But what if your project isn't standard? What if you want to add a custom display or some really weird specific logic? That's where you can start to bump up against the walls of the framework.
So it all comes down to a trade-off, right? On one side, you've got ESP Home. It's fast, it's simple, and its integration with Home Assistant is just seamless. It is fantastic for probably 80% of sensor and switch projects out there. But on the other side, you have custom code, maybe in the Arduino IDE. This gives you total, absolute freedom. If you can dream it up, you can code it. It's more work, for sure, but you have complete control. So look, the takeaway here isn't that one is better than the other. It's about picking the right tool for the job. You're building a straightforward temperature sensor for your house? ESP Home is a no-brainer. You're building a custom weather clock with an e-ink display and 17 different animations? Yeah, you're going to want to fire up that IDE and write some code. And that's really the question I want to leave you with. For your next big project, what's more important to you? Is it speed and ease of use? Or is it total control and unlimited flexibility? There's no wrong answer, but it's a choice you'll have to make.